Hello, everybody, and welcome to the Kube Korner show. Today, we've got a really special guest. It's Matt Bader. There we go. I always mess that up when I start someone's last name. I practice and I do it wrong. Um, so Matt
I,
is a Veeam Kasten superstar. I've known him for a few years now. He created some great training courses at Kasten. He's one of their top engineers, excellent presenter, and he's here today to talk to us about OpenShift and automating OpenShift data protection. First and foremost, I want to ask Matt more about himself to tell us a bit, and then we'll talk more about what OpenShift is.
yeah, great. Thanks, Jeff. I've been called worse things for the record, so no problems there. But yeah, as you mentioned, I'm a solution architect that's part of our Kasten product team, and that means I have the pleasure of wearing a variety of different hats. Whether that's I try to spend as much of my time hands-on as possible. I'm a tinkerer like you. I think this is why we get on well. But a lot of that is just working with customers and working with partners, identifying what it needs and requirements for oftentimes it could be related to something we'll talk about today in deployment of Kasten, but a lot of times it's capabilities required to protect specific workloads, right? Like that's the you and I both come from the virtualization space. VM backup is a very infrastructure centric concept, right? Primarily talking to a hypervisor, and what is inside of one VM oftentimes doesn't matter from one to the next to the next. There's I'm oversimplifying somewhat, but on the Kubernetes side, like applications are the infrastructure in a lot of ways. Things are so tightly entwined, and this is an incredible, we just entered the 10th year of Kubernetes this year, and the ecosystem is enormous and continuing to grow and grow. And I think a lot of that is because of the expandability, the customizability of Kubernetes compared to hypervisors that we've seen in the past, and that creates both opportunity and frustration. Everyone that I think knows me even a little bit knows how much of a fan I am of the phrase that the good news is you have options, the bad news is you have options. That can be Kubernetes to a T sometimes. So it's a really fun. I consider it a privilege to get to work with folks that are trying to figure out the difficult problems in this space, and bring them to life.
That's great. And the one thing I like most about Matt is that when I first started learning Kubernetes, it had been kind of developer centric. And so the people who were evangelizing it sometimes were just difficult to understand, or they talked very little to begin with. They just assume you understood it. And so Matt's got a great talent of, I would say, humanizing it, because I've had people who have just started learning Kubernetes and go, my goodness, this is just, and it is a bit of a learning curve, to say the least. So that's really interesting. But how did you get involved data protection particularly?
How did I get involved
Yeah.
in data protection? Yeah, I mean it's one of those it's one of those topics that I think, again, anyone that came from the infrastructure space, the virtualization space, knows how critical it was. Seeing the evolution going from like 2005 and beyond, of going from this sort of agent based physical host model to having products like I was a Veeam fanboy, a decade plus before I ever wound up working here, and that was as a home user of things like ESXi, to do those backups. So I think it's especially home lab folks, or folks that are very hands on. It becomes a necessity, right? You are your own, I run what I consider to be my own production infrastructure for various things, whether it's in the basement or in the cloud. So you can't data protection is something you can't escape, right? Despite the fact that too many people, I think, mistakenly consider business continuity topics as afterthoughts to building new infrastructure or building some new solution. It's an unfortunate reality, but eventually, whether it's day 2 or day 200, like you will learn data protection, or you will feel pain if you are an infrastructure person. And I think it presents so many different challenges in the Kubernetes space, and it's obviously we're continuing to see adoption of more stateful workloads in Kubernetes. So it's not the fringe concept that it might have been 5 years ago, where okay, I'm only running Kubernetes for stateless portions of my application. That's become much more of a mainstream topic. So I hope to not, I hope to be one of many experts in this space rather than one of a very enjoyable handful.
Yeah, and it's interesting you point that out, because when I first started learning Kubernetes, I kind of at the same time found out about Kasten. And while I was talking about Kubernetes being complicated, one thing that I always liked from the get-go of Kasten was that it wasn't. So Kasten made data protection much simpler for someone like me. If you intuitively know data protection because you've done it before in your VMs or your physical machines, the Kasten interface, whatnot, I was able to figure that out. And I even did a test once at one of my previous organizations. I showed a salesperson a Kasten GUI. Now, this person knew enough of Veeam to be able to create a backup, and this person was able to create a backup. I said, well, there you go. And that's really important, because what we're finding is all data is under threat now from various attacks, especially ransomware, and you have to have data protection. And what you don't want is to have a situation where you have to have a PhD in something to create your data protection, right? That has to be straightforward and easy to do. So I think we're all aware now of the threats, and you want an easy solution. So moving forward, talking about Kubernetes, we're going to talk today about OpenShift. And I always repeat this because people sometimes ask me about what's the difference between these distributions and things. And I use this analogy, which I don't know if it's correct or not, but with Linux, simply because it's an easy one, whereby you have the Linux kernel, but then you have all these distributions. And so they come in different flavors. Some are stronger in other areas, some are weaker in other areas. They have their roles. That's slightly similar, I would say. There are a lot less distributions of Kubernetes out there, but I've heard people say, well, this one does this better, this one does this better. What we're going to talk about today is OpenShift, and you're an expert in that. What do you think about that, and what would you say is OpenShift's big plus?
Yeah, so it's a good analogy. The Linux distributions to Kubernetes distributions. You think about some might have their own specific package management technologies. Obviously, commercial support is a very big related topic there, and that I think is for enterprise consumers of Kubernetes something that certainly matters. The majority of conversations that I have are with people that have some commercially supported variant of Kubernetes. I think you either have to be very bold or very well resourced, right, to go the vanilla upstream route and solve all every new problem on your own. So that's far and away the biggest value of OpenShift is having the expertise of Red Hat engineering and support behind that. But it stands alone somewhat in terms of the rest of the distributions, in that it really it's not just about the Kubernetes engine component of OpenShift. It's almost like, again, because I know we've got a very common Veeam audience here. It's like comparing ESXi and vSphere or the capabilities that vCenter would grant you, right? Is having all of these other higher order management capabilities. You mentioned that Your experience with Kubernetes early on was very developer centric. They really appeal to tooling that's required of both developers that are creating applications that run on OpenShift infrastructure, and to those, whether it's SREs or platform engineers that are, responsible for the infrastructure components of OpenShift. And extend that to, one of the things that I'm hoping we get to talk about today is OpenShift GitOps and the validated pattern framework. We'll get into some of. So again, it's not just about Kubernetes. It's all of that other management capability on top. And
Yeah.
I don't think anyone does that in as big a way as Red Hat does.
Yeah, and especially one thing that's really interesting is when I was describing Kubernetes to people, especially vanilla Kubernetes, and I said, well, there's no users. Like, what do you mean there's no users? Well, you have to do this, that, and the other, and the eyes just drop. Well, when you get a distribution like OpenShift, that's all baked in. So they are really giving you something you can use right out of the gate. And also, there's a lot of specialized training as well for it. So that's very important. And you're right. I don't know of anyone who's actually built their own Kubernetes in a major production and are using it, simply because even if you're extremely good and you know what you're doing, there's just so many components involved in Kubernetes. If anything goes wrong, you just wouldn't have the time probably to fix them all. So that's a major reason to go with a distribution. The only thing I'll also mention to people here who might not know is there are little differences. So for instance, there's a command in OpenShift, it's OC instead of kubectl, although you can use kubectl as well. And little things like that. And then there's something called operators, which are present in Kubernetes, but they're, I wouldn't say extremely, but they're heavily used in OpenShift. So can you describe to us what an operator is and why or how much more OpenShift uses these?
Sure. So it's, trying to think. That's a bit of a loaded question, but I'll come up with something here. Well, I mentioned before your comparison of different Linux distributions, and I might have apt versus some other package management solution across different distributions. Somewhat you can look at OpenShift's what they call the operator hub as a dedicated flavor of doing distribution of Kubernetes applications, right? In the same way that it's a storefront. So you certainly can leverage, and some applications do that same operator framework to deploy applications, just through. So the other method that would commonly be used is a Helm chart, right? Yeah. And that's something that I could use across OpenShift or other distributions. The operator provides, opportunity to better integrate into OpenShift. They've actually got various different levels 1 through 5 of different operators that really just represent different integrations and automations within that particular operator. But there's not a big fundamental difference there. It's ultimately about just distributing, deploying, lifecycle managing an application. So again, could be done with Helm, could be done with the operator. Depending on the application, you may not have a choice. Kasten does provide that choice of saying, hey, if you choose one or the other.
And are the operators specially tested for OpenShift? So that's one of the things that I believe some other distributions have, is that the packets that are in their marketplace or their operators in their marketplace have been tested with distribution, so that you don't end up in scenarios like if you're doing your own Kubernetes, that you do a Helm install and you end up breaking a bunch of other things.
There is quite a bit of validation that goes into publishing new versions into the operator hub. I think that's in an area where Kasten engineering has earned themselves gold medal after gold medal in that, we release every 2 weeks. So there are there aren't many teams that have more experience than Kasten Engineering in terms of regularly publishing to that marketplace.
That's wonderful. So yeah, and I'm going to say like that every 2 week release is, I tell people about Kubernetes release cycles, like, whoa, they must all have ulcers, testing. But so tell us more about what you want to show us today. It's in relation to OpenShift, and I believe it's automation.
Yeah. So two things. Yeah. So it is related to automation. So what you were just mentioning of things in Kubernetes move fast. So we need a way to be able to manage whether it is Kasten or any other Kubernetes application. Doing that at scale. But the other thing I wanted to tie into this conversation is a capability within OpenShift called OpenShift virtualization. And so this is one where I think we'll probably forego slides today and just maybe jump into a live environment and have some more fun. But just in the way of introductions, OpenShift virtualization kind of blends together a couple of the topics we've talked about so far, in that it's about running virtual machines on Kubernetes, which on the face of it, for a lot of people probably sounds crazy. So like, what are the things driving people to do this? There's I'm sure, Jeff, you can probably think of a big one right now that might be driving people to consider alternate hypervisors, and we don't need to throw any of those stones necessarily. But there are plenty of other reasons. Certainly for organizations that no one goes through digital transformation overnight, right? Kubernetes is a data center and cloud platform of the future, and that it provides this incredible level of abstraction between on-prem environments across multiple different cloud environments, such that I can make one application once, run them anywhere, move them anywhere. So I'm in a position where I, as a business, want to start building net new applications on this platform. Maybe there are applications that we want to rewrite to take advantage of some of Kubernetes capabilities over time. But in reality, there's also many workloads that are never going to become truly cloud native workloads. There are things that maybe just well out of support and just work, and no one breathe on that VM because it runs a very important part of our business and we're all too ashamed to talk about it. Everyone has some version of that. So having a single platform wherein now I can run all of my cloud native workloads, as well as have this unified management experience for all of those VMs that whether they're not going to be transformed tomorrow or they're not going to be transformed at all is immaterial. I get all of that, really under a single roof, and actually still have those benefits, right, of this level of abstraction, whatever management automation I might build on top of this. I have the same ability to now take a VM that I'm running in OpenShift running on AWS, and then can easily move that to OpenShift running on premises. So I think there's there's value in that consolidation. We've definitely seen this big uptick in interest in the last year of so the underlying project is an open source project called KubeVirt. So OpenShift virtualization is just the commercial their commercialized implementation of that KubeVirt project. And I think so where does all of this apply to Kasten and to me? Not every Kubernetes native application is a stateful application. We've talked about this. every virtual machine you run on Kubernetes is 100% a stateful application, right? This is an inherent truth. There's no way around it. So if I'm running virtual machines on Kubernetes, I need a way to protect those things. And that's where we introduced support for OpenShift virtualization workloads. It's probably been close to 2 years now, and we're continuing to make enhancements to this and trying to grow with the ecosystem. But a project that I've been working on here. Let me share my screen.
And just the fact to have a YAML file with a VM, I still find that fantastic.
Yeah. I mean, is that really any different at the end of the day than a
Yeah.
VMX file?
No.
All right. You can see my screen here, Jeff. Awesome. All right.
Perfect.
So the project that I was working on just this past month is what's called a validated pattern. So validated patterns. This is a project that's built and maintained by Red Hat. So engineers within the OpenShift team. And what it essentially is really an opinionated GitOps stack for OpenShift. So actually, well, maybe I'll bring over a slide or two for illustration purposes. Let's go ahead and do that. There we go. So this was from a separate presentation, but just a little intro on that validated pattern framework. So the idea here, I'm sure everyone has used whether it's reference architecture documents, solution guide documents, blog articles, examples from GitHub, Stack Overflow, you name it, right? When you're deploying some new solution, some new infrastructure, Jeff, you go through this, you go down this rat hole several times a month, I'm sure, right? Yep. It's just getting started on deploying a new thing. The problem with most of those resources, though, is that a PDF, as soon as I put it out into the world, that thing is already out of date, right? The neat thing about the validated patterns is that it really is configuration as code. So this is a living, breathing repository that I can fork from Git. And the idea is to be able to, really easily, rapidly apply this particular pattern to one or multiple OpenShift clusters. And that's going to, as we'll get into my example, go through deployment of storage, of OpenShift virtualization itself, creating VMs, deploying Kasten, and then enabling the protection of those VMs. But as obviously as new versions of Kasten come out, as new versions of OpenShift virtualization, of OpenShift itself, the underlying storage, that compatibility matrix becomes enormous, right? So the cool thing about validated patterns is that they allow you to test what is effectively this living, breathing reference architecture as part of a CI/CD pipeline. So we can easily identify, oh, hey, this change has broken something within the existing pattern. So it makes them very easy to stay up to date, to extend, to allow for collaboration with other partners, right? The validated pattern that I'm going to be walking through it started out as a Red Hat validated pattern that I extended to include the Kasten pieces, and then a customer or any other user could pick that up, deploy that same pattern, and make changes that suit their own needs. So it really framework really is the right word. But I think the core concepts here to understand, certainly for those of you that aren't familiar with the idea of GitOps itself, is all about being able to put source control in front of all of these declarative manifests that I'm using to instantiate a virtual machine or a Kasten policy or a Kasten location profile, declare that desired state and be able to continuously monitor that repository to look for changes. So are pulled automatically, looking for changes to that desired state and then applying them to that environment. Being able to move back and forth through version changes. It gives you, again, an entire change management process in a box. But that's just one piece of this, right? So GitOps would be, again, how I'm deploying and lifecycle managing a lot of those Kubernetes native resources on the cluster. But the validated pattern framework itself takes that one step further, right? GitOps is not the only kind of tool that I need in my toolbox to solve really what is a larger question of automating infrastructure deployment, but also that ongoing state management, making sure I don't have drift, making sure I can continue to apply updates. So the key piece of this is OpenShift GitOps, which is based on Argo CD. But other interesting things that Red Hat has built into this framework. So GitOps is declarative. Ansible is an imperative tool, right? It's doing wanting to launch one-off playbooks to stage something. For something like running OpenShift virtualization VMs, I could declare the state of those VMs, create them, but I might still need some configuration management tool after I've deployed from this template image to then go stage out, whatever other applications might need to live on that VM. So integration into Ansible. One thing we won't really cover today, but Red Hat ACM, or Advanced Cluster Management, is a tool that OpenShift uses to manage multiple OpenShift clusters. So this is great when I've got a large distributed environment. I could deploy kind of a hub cluster with a primary Kasten instance, and then be able to use ACM to manage the staging of secondary clusters, each of which, again, the OpenShift upgrades, all of that could be managed through ACM, but would also still see automated deployments of Kasten. And then the biggest thorn in the side, I think, of anyone doing GitOps is often secrets management. So we use Kubernetes secrets for everything, right? It's credentials for accessing a bucket where we're going to back up data is a great example of that. So I need to get these secrets into that cluster. I need a secure way of bootstrapping all of that. There's, again, the good news is you have options. The bad news is you have options. I think this is a benefit of this being an opinionated solution, is that it's kind of giving you all of these capabilities out of the box. So the end goal here is taking, this is a very complicated diagram of the initial Red Hat validated pattern. So what are the things that we care about here is essentially, this is going to be declaring some resources that are provisioning our VMs, and it is also provisioned OpenShift data foundation, so Ceph as the underlying storage. It's deployed that Ansible automation or Tower instance, and the OpenShift virtualization controller. So this was like the standard Red Hat pattern that we started with. And then we see just small changes here. We'll look at them closer in the live demo. But it's really just layering on then Kasten into this environment, and providing some other configuration resources, so that we'll be able to protect these VMs, but also just to be able to deploy Kasten with a lot of the other sort of post-install configuration done, automatically as a result.
Okay, if you have a lot of clusters, that's really important because you don't want to go in
Yes.
around and manually install. Also, I'll mention one thing with the secrets. People might not know that Kubernetes secrets aren't secret. So that's one big problem. That's why you leverage something like HashiCorp, because all they are in Kubernetes are base 64 encoded. So if you encode them, you see the secret. So everyone in production tries to use something like HashiCorp. There's other things called sealed secrets, I believe. But especially if you need to go to GitHubs and have something happen, you need to have these secrets or like passwords or tokens. And that's where you're going to leverage something like HashiCorp.
Great point, Jet. So yeah, if I, just as an example here, if I get the output of one of my secrets, this is all getting destroyed after this session anyway, so I'm not
I was
worried.
going to write them down. No.
Yeah, but so as you mentioned, if I look at one of my secrets in my Kasten IO space right now, I see all those data fields associated with it, and yeah, these are just base 64 encoded. So yeah, we want a secure place to be able to put all of those within the cluster, or within some centralized environment, because these secrets I don't want living within my Git repository. Sealed secrets, you mentioned, would be one approach to be able to do that. I've seen people use it with successful outcomes. I still think it leaves opportunity to accidentally commit actual secrets into Git. And that's why I really like this approach that Red Hat has taken with integrating the external secrets operator, and we can kind of look at what that means. But just looking at this from a getting started perspective. So again, I could start with just a vanilla OpenShift cluster that I've installed to AWS in this case. If I look for my OpenShift virtualization, data protection with Veeam Kasten, this is the specific pattern. Within the getting started section here, it walks you through step by step what you need to do to deploy this thing. And so a big piece of that is this initial bootstrapping of these secrets. So the pattern itself exists in GitHub. I would go through and fork that to my fork a copy to my own repository and clone that down. I've already done that in this particular case. We've got one here. Yep. But once I've forked that, I can clone it down and look at deploying that pattern. So if I bring up the pattern itself, let's collapse some things down here. So this is again just that same Git repo. But it really, all you need to do effectively to get started is follow that documentation to fill out for your environment what are these different secrets that I want to set. So this is a file that again would only live on your local system to do that initial bootstrapping. So it's simply a matter of again my AWS creds. Hey, what do I want to set as the SSH key pair for any VMs that I provision? I need a cloud init to set the user password for those VMs. Because this is using Ansible, it takes in an Ansible license file actually as a base 64 encoded secret here. And then one of the ones we've added that's specific to Kasten is Kasten DR. So the policy that allows Kasten to back up itself, right? That has a separate passphrase associated with it. So that's how we would get all of these populated into the Vault instance, the HashiCorp Vault instance that will be provisioned to this cluster. So if if I were to fill out all of those specific to my environment, um, and then actually there is one Kasten piece here covered in the documentation as well. I couldn't make this fully self-contained because we need to back up data somewhere. I didn't want this to just make snapshots, because snapshots, Jeff, are famously not what? They're
Backups.
not backups. Exactly. So the only other thing that you would need to change in here is specifying a, in this case, I built it to work with AWS S3 buckets. It could easily be extended to support other types of Kasten location profiles. But it's essentially just saying, hey, what is the name of the bucket that I care about sending these to, and what is the, from my secrets that I just defined, what is the secret that holds my my AWS credentials for accessing this? So only things that I would need to change, and then could come through, and here we go. There we go. Oh, sorry. So from the very top here, this is just the, because this is a pre-baked environment, right? This is the only command that I need to run to start staging that after I've filled out that secrets template and that Kasten information, is the pattern shell script, pattern.sh, make install. And what this does is rather than require you to install a whole bunch of other tools, it just uses Docker or Podman to launch a container with everything else in it that it needs to start doing the initial bootstrapping of that environment, which is primarily the installation of Vault and population of those local secrets into Vault itself. So there's no other input here. It runs for a few minutes, and then we're ready to look at that live environment, which is hopefully where this will start to make a bit more sense. So we would have gone from having so this is my OpenShift cluster. Other nice thing about OpenShift, like the UI for doing anything, is just, if you are not a proficient kubectl/OC user, this is nice. But we can see here, originally we would have had nothing, no other operators installed on this cluster other than our validated patterns operators. So we actually, if we drill down into that, I should see that, yes, so this is running one instance of my Ansible Edge GitOps Kasten pattern. So this is, again, corresponding to this repository ultimately. If we look at go a bit more in the weeds, look at the YAML for that, we can see what specific GitHub repository this is aligned to. So that went through, and what it ultimately did for me is it deployed and configured OpenShift GitOps, OpenShift Data Foundation, so my underlying Ceph storage, enabled OpenShift virtualization, enabled Ansible automation platform, and Veeam Kasten. And we'll take a look at back in that in the pattern code itself, how it's doing some of those pieces, how we can influence this configuration. I'm sure you're not going to walk away in the next 10 minutes understanding the ins and outs of this, but I just want you to get a sense for, again, how this can be then modified to give you that management control. So we'll look at a couple of things here. So Veeam Kasten itself, I think I've already got, well, we'll go from the OpenShift console. If I look in networking and routes, so routes are like ingresses, how I would access a specific service running on that cluster. We see part of that Kasten install was creating this K10 route. So I can bring up that Kasten UI, which I think has been logged out. Yes. So that's one of the first things we'll notice in here that I've done as part of this automated configuration. By default, you wouldn't have a route created. You wouldn't have, if this were just a plain no value set configuration, you wouldn't have a route. You wouldn't have any kind of authentication. we can see here this is actually using Kasten's integration with the OpenShift OAuth server. So I can provide that multi-user self-service experience. In this case, I don't actually have any other OpenShift users set up, so we'll still wind up logging in as kubeadmin. Hopefully,
And that's a huge factor too, because that's another complaint point I hear from people when they're just doing it themselves is they just end up using the K10 service account for everything, which isn't best practice, obviously.
Right. Good point. All right. So we'll log in. Yeah. So I've got Kasten up and running, and we'll see within Kasten itself a few other things that I've configured as part of this deployment. So if I look at settings, so K10DR, we can see has already been enabled. This is something that, again, from a best practices perspective, anytime you're running Kasten and backing up applications, you should have that K10DR policy enabled, because that's how Kasten is backing up itself. It's how I get back my catalog if something genuinely terrible happens to this infrastructure. So we see that that's already been created. In order to create that policy, I need a location profile, right, to send backup data to. So if I look in location profiles, we can see I've already created my location profile that points to that bucket that I mentioned from the initial values file. And we can see immutability is enabled, configured. Great. And then also we have a policy for backing up our namespace that has a couple of different VMs. So essentially out of the box, ready to go, ready to start protecting things. So how did we ultimately do any of this? And that most of this comes down to the magic of OpenShift GitOps or Argo, is because Kasten itself is just a Kubernetes native application. It's really no different than the applications that it protects. It makes it really easy to deploy and manage using tools that are meant to deploy and manage Kubernetes applications. It's not like a crazy leap of thought there. So within this chart, we'll start kind of from the beginning. Within values hub. So hub in this case, I've only got the one cluster, but hub could be truly a hub cluster and then having multiple other secondary clusters as an example. But in this particular case, we see at the top level here, adding things to an existing validated pattern is pretty straightforward. It comes down to a few different things. So I need to create some namespace on the cluster to put my stuff in. So we see that Kasten.io has been added in addition to some of these other things that were installed by the pattern, right? So again, Vault, the external secrets operator, CNV is cloud native virtualization. This is OpenShift virtualization, and ODF. The subscriptions portion of this is if you are using the OpenShift operator hub. So a subscription refers to deploying that particular operator. So in this case, I am, rather than just using a Helm chart, I am using the Kasten operator. So we can see this is just referencing where is this going to go within the what operator hub source is it from. There's a few different ones on the back end, but it ultimately it's like, hey, what is the name of this thing that I'm trying to add? So we've created a namespace, we've added an operator. We won't dive into the imperative pieces, but so the applications, this refers to ultimately an Argo application that is going to be created by the pattern. An Argo application deploys whether it's some group of manifests or a Helm chart often, and does that ongoing continuous reconciliation for those resources. So this is essentially telling it what are the applications we want to create, where within my repository are the specific files for that application. So again, we see the ones that are created by default within the pattern: HashiCorp Vault, OpenShift virtualization, ODF. This is what's deploying our virtual machines. We'll come back to that one. And then we see two here that I've added now for Veeam Kasten. So Charts Hub Veeam Kasten and Charts Hub Veeam Kasten config. So that was all at the top level, all that we needed to add some new apps. But let's dig a little bit deeper into what is in each of these. So within, again, Charts Hub Veeam Kasten, we've defined some this is not the Kasten chart per se. This is just an arbitrary representation. So this is a chart that's defining my application that I want to create this deployment of the Kasten app. And you can, the other neat thing about this framework is it makes it easy to layer values files, so you can define things at like a top sort of global level, or on a per group of clusters level, on an individual cluster level, or things that again become like overrides for specific environments. So you've got a lot of granularity there in which you can apply these things. So like in this particular case, obviously I would want to just do the EULA acceptance as part of my deployment as well. I could hard code some of these things, or again, having this abstraction would allow someone, when they come in, fork this thing for themselves, put those values in and have them apply to that environment. Those could be within this app, or again, they could be if it's going to be the same across the entire environment, they could be treated as more kind of global variables as well. But if we look at, where the rubber hits the road for deploying Kasten itself, when we're deploying from the operator, we're essentially deploying a K10 operand. That this is basically the spec of this aligns with if I were doing a Helm-based deployment. It's just the Helm values, right? So this is all of the things that I would want to set when deploying Kasten. And we could see some of these things, might make sense to be completely hard-coded. Other ones, we're going to need some dynamic variable insertion. In this case, our EULA value is great. We've some end user configuration for that. But for configuring OpenShift, that OAuth integration, so that's giving us our multi-user auth in front of the dashboard, I need to know what my URL is for the OpenShift API server, and I need to know my route address for Kasten itself. I know the bases of these things, and the validated pattern is going to give me another variable that I wouldn't have otherwise, to be able to pump in, hey, what is that, the fully qualified domain bit, so I can dynamically deploy that to, again, any cluster. And then we see I'm configuring my route. I'm setting that new quick mode for Kasten DR, and I've also just to clean up the UI some, added these exclusions for all of the kind of system namespaces for OpenShift that I'm probably not using Kasten to protect any of these things. So I just don't want 70 extra things to show up in the UI.
That's really useful.
Yeah. So this piece, just deploys Kasten, but again, we're able to take advantage of these these variables. If I look here so I haven't shown you like what this looks like in Argo yet. So these are all of the different applications. Then you'll see the names corresponding with everything we saw in those files. So these are all of the individual applications that get created. If I drill into Veeam Kasten, if we look at maybe those details and parameters, I can see, oh yeah, global .cluster domain is going to populate that Kube Korner .8, So great. And now I can see, all right, what has actually been provisioned by Argo here was really just creating that K10 resource. And that is what led to, all of these other child resources. These are all of the deployments that make up Kasten itself. So if I wanted to make some change to my deployment, let's say that I wanted
Update,
to,
upgrade or something, or
yeah, well, it could be for upgrading purposes, or like we could do something simple here and just say, all right, I want to remove this. I do actually want that, just the OpenShift namespace to show up there.
Mhm.
This is the GitOps workflow. Actually, you know what? We'll come back to the GitOps workflow in a minute here. I want to show you a better example of
Mhm.
that. So the other piece to look at then is the Veeam Kasten config application. So this is after Kasten has been deployed, what are all of the other resources that I want to create? So we can see here I'm defining a policy preset, so basically a template that other users could use for creating their policies. And again, we see we're using those dynamic variables that we can pump in through the framework. So in this case, out at the very top, I defined an idea of a default location profile. So if you didn't override it with something else, it would come back to what we defined as the one location profile that we created initially. So great, we create a preset. As I mentioned, we need to configure that K10DR policy. So this is where the external secrets operator comes in. I don't need to put an actual Kubernetes secret in here with the passphrase that I've chosen. I can reference this as an external secret. I can reference the vault that was created and bootstrapped by the validated pattern framework. And then we're saying, hey, within this location, I want you to create a secret called K10DR secret that is referencing another path within that vault. So I've got a secure way to put all of this in source code repository, while at the same time at runtime being able to access the actual secrets that I need. Cool. So we've got that secret. We create the policy. And that also, again, is referencing what is my default location profile. And location profiles itself. So this one I went a little crazier with. You could just do again, all of these could be very static manifests, but I'm thinking about, what would, if someone needed to create many different location profiles and wanted to do this declaratively, all right, maybe they don't have to define each and every one of these. Again, the benefit with Kasten is I could, because all of our resources are just Kubernetes native API. So I could create, a profile.yaml file for every one of these that I want to create. But in this case, I'm leveraging some of the capabilities of Argo to say, all right, I want to basically treat this as a loop and abstract this. So what it would allow me to do is, and this is the example I wanted to show you, is out here in my values Kasten file. So we saw we had location profiles and we had one of these defined here. This is obviously not all of the information that you would need to define a location profile. But because I've abstracted this for my use case, that really is all I would need to fill out to add another one. So we can see here, I've already have one kind of commented out, that if I uncomment this, so this would add a new Kasten location profile, my extra profile, using some reference credentials, and it's going to point to a specific bucket name. So if I just go through and save this, we'll go back to my GitHub client here, so we can see that, oh, am I looking at the wrong? Oh, never mind. Sorry, that's because I hadn't selected it yet. So you can see here, great. We've uncommented that, and I'm concerned now. I went one line too far. Oh no, that's just wrapped. Okay, so we've made that change. All right, great. I'm going to commit that change, and I'm going to push that in a real environment. You would probably do that as push that into a branch and then do a pull request back into the main branch, right? So you have the opportunity for other people to review that change, suggest changes, reject it, whatever it happens to be. That's where your change control process takes place. But we push that change into the repository. So if I come back to Argo now and say within Veeam Kasten config, if I refresh this, it should notice that, oh, it's out of sync. There's been some
Hmm.
change. And now we're going to sync that. Um, Great. So that'll run. Oh, that's the other thing we added in here was another job that would run after syncs to uh, annotate volume snapshot classes with the
Oh,
Kasten annotation because I need that.
yeah.
Or there might be certain storage classes where you need to do block mode annotations. Um, so long story short, we went through, made a change, refreshed that. If I go back into Kasten now, on this tab here, and we'll go back to location profiles. There's my extra profile, no immutability, pointing to that extra bucket. So it could be the same thing there to say, okay, I want to update my definition of the VMs, which could, go from having 2 virtual machines here to 3 virtual machines, or a new namespace with additional virtual machines. Um, and I know we're just about right at time. That's probably the most important piece of all of this is,
Yeah.
great, we've deployed and configured Kasten, but then within whatever namespace is my VMs, and it doesn't have to be VMs. It could, like, this approach is applicable to anything.
Yeah.
I've actually got my Kasten policy object defined there because typically it's going to make sense to keep the definition of how this thing is protected with that application itself, with what you're using to deploy and update that application. So again, being able to dynamically pump in the variables that I would need and create at runtime that policy, which we saw already exists, and I think we should be able to see has been successfully running and protecting our VMs as well. So snapshotting VM 001, 002. Because we're right at time, I'll ask you to trust me that if I deleted
Yeah,
one of
no, I
these,
mean it's wonderful.
actually,
I like about this is, again, if you're dealing with big environments, this is exactly what you need, because a lot of people I know are testing Kubernetes, playing around with it. And when you're in your lab, you're doing this, like, it's a lot simpler. But then you start to imagine, what if I have, as you said, like multiple OpenShift clusters? You really need a solution like this. The one thing I will ask you to point out here, because I like looking at this, if you go down into the actual backup and show the new type that's appeared, I actually screenshot this from our organization. Look, type virtual machine. It's like, what? I thought you said it was Kubernetes, because it should be in there somewhere.
oh yeah, way.
I thought that was cool. I like these things. You've been doing Kubernetes for a while, and then you see virtual. I just noticed it. Type virtual machine.
Yeah,
There it is. Yeah, my virtual machine. So I really enjoy that. And a KubeVirt IO. But
yeah.
well,
And
that's
I mean, there
fantastic.
are certainly still challenges with managing with because you're expecting that people are familiar with
Yeah.
Kubernetes and namespace constructs, and that might not always be the case for people considering that move to something like OpenShift virtualization. And that's something we're continuing to explore approaches of how we would make that even simpler, even more approachable for folks that don't necessarily have that same cloud native background.
Well, that was fantastic, man. I mean, this is one of these demos. We just go on forever. It's so much fun, and
Oh
this
yeah,
I
yeah, we can hang
really,
out and
I
keep talking
don't
about
really
this all
type
day
in
for
it,
sure.
but I really appreciate that, Matt, and thank you very much, everyone who joined us. And we'll be back next month, hopefully, or the month after that. We'll see. The holidays can always interrupt, but again, I want to thank Matt for this. It was a fantastic show and demo. Thank you very much.